everyone. We are going to begin the procedure part 1 of the oscilloscope lab in this video. So essentially, the purpose of this lab is to get familiar with using the oscilloscope and the controls and the function generator. Okay, so we're just going to go through the steps on the lab sheet. So everyone should have their procedure out and their data sheet. Here's what you're going to do is draw some waveforms and write down the data and do a couple of calculations. So let's begin. Okay, so step 1 is to connect the function generator output to channel 1 of the oscilloscope. So we've done that, and I have turned the power on both devices. Okay, so now we're going to check the calibration of the oscilloscope channel 1 by switching the mode switch here to ground. That puts 0 volts on the input to the oscilloscope, and I like to put the trace on the center line for 0. So you just adjust the position here, okay, the position knob right here, until the trace is centered on the center line. Okay, so that reflects 0 volts. Okay, so now and I also like the beginning of it to start at the beginning of the first square. Okay, so I'm adjusting the beginning of the sweep using the horizontal position to the first square. All right, now I'm going to switch that back to AC mode. And now I want to get a sine wave with a frequency of exactly 100 hertz. Okay, so looking at the function generator, I have basically pushed the sine wave button right here to get a sine wave output, and I have pushed the 100 hertz button right here. Okay, so whatever is on this dial right here will essentially be multiplied by 100 to get 100 hertz. Okay, so that's set at about 1, so that's about 100, should be about 100 hertz. Okay, all right, so the time scale on the oscilloscope is set at 1 millisecond. Okay, there's the time per division scale, which means that each square on the screen is worth 1 millisecond horizontally. Okay, so you probably want to write that down on part 1 for the first one. Okay, and then the calibration knob here is turned fully counterclockwise. Okay, and then we're going to go to the volts per division scale. The volts per division scale is on 1 volt per division. Okay, right here. There's 1 volt per division right there. Okay, and let's see if that will focus. Okay, that's 1 volt per division. Okay, and you'll see here that you'll see here that the signal is we want to set the trigger level here so that it triggers. Here's the trigger level. So we want the trigger to be set on auto. Okay, auto triggering, and the trigger, we want to adjust this knob right here so that the voltage triggers on 0 volts on the upgoing slope. Okay, so I'm just setting the beginning of that waveform to be right on the 0, and that's where the waveform will start to display on the screen each time. So then we want to get a full scale reading. So I'm going to adjust the amplitude of the function generator, which is this knob right here, the amplitude of the function generator, and we're going to increase the amplitude so that this fits the full vertical scale. Okay, just like so. So there is the waveform that you should get. Okay, so you're going to write down on your data sheet here. Okay, you're going to write down on your data sheet the time per division is 1 millisecond. The volts per division is 1 volt per division. And now we're going to measure the peak voltage. Okay, the peak voltage is basically 4 squares high from the 0. So that's 1, 2, 3, 4 squares to the peak exactly. And you multiply that by the volts per division, which is 1. So therefore, the peak voltage is 4 volts peak. Okay, so I'll write that down on the data sheet right there. Okay, and then the period is the time for one complete waveform. So we're going to measure the number of squares across here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares across the screen. So one complete waveform is within 10 squares, and the time per division, or time per square here, is the time per division here is I'm trying to get it to focus. Okay, the time per division here is one millisecond per square, so that means the period is 10 milliseconds. Okay, so I just wrote that down there, 10 milliseconds. So there's 10 squares. Okay, so we have, so essentially this is 3 times 1 volt per division, right? And this is going to be 10 times 1 millisecond per division. Okay, so that's how we calculated that. Okay. All right, so let's go to the next part. The next part is we're going to change the volts per division. You need to draw this waveform. So this is a point where you may want to stop the video and draw this waveform on your data sheet. Okay. All right. So now we'll go to the next part. We're going to set the volts per division to 5. Okay. So now I have changed this knob to read 5 volts per division, and you can see that the waveform has changed. Okay, the waveform has changed. So now you're going to draw this waveform on the next block, okay, on your data sheet. All right, and that looks like this would be a point where you could stop the video and draw that waveform. All right, the time per division did not change, so we did not change that. That's still 10 milliseconds. Okay, so the period did not change. I'm sorry, 1 millisecond per division. And so the period still did not change, so we still have 10 milliseconds for the period. The volts per division changed, which is 5, but we didn't actually change the voltage of the signal. All we did was change the scale, so we should still get a signal of 4 volts peak. So let's take a look here. So if you look at the increments on this scale right here, okay, there's each one of these little lines is 0.2 of a square. So we got 2, 4, 6, 8, 0.2. So we got about 0.8 of a square. okay, there's 0.8 of a square to the peak of this signal, I'm going to say. 0.8 of a square, so 0.8 of a square times 5 is 4 volts, okay? Okay, so it's 4 volts, which is 0.8 times 5. Okay, so here's the data that I wrote down. Okay, we have 1 millisecond per square. We got 5 volts per square. The peak voltage is 0.8 squares times 5, which gives you 4 volts. Just like before, we still have 4 volts peak. And the period didn't change, okay? We didn't do anything to the scale, so we still have a full waveform across there, okay? A full waveform across. So the period is still 10 milliseconds, okay? All right, so now we're going to go to the next part. We're going to change the time scale to 2 milliseconds. Okay, so essentially we're going over here to the time scale, and I'm going to switch that over to 2 milliseconds, okay? 2 milliseconds. And now you can see that I have 2 waveforms in here. So I basically doubled the time it takes to sweep to get from one end to the other, okay? Which is enough time for 2 complete waveforms, okay? So, because we didn't change the frequency on the function generator, so the same signal is going in, we just changed the scale, okay? So let's write down, we wrote on our data sheet, we have 2 milliseconds is the time for division. The volt per division is still on 5, okay? We didn't change that. Okay, so therefore the peak voltage didn't change. We still have 0.8 volts. We still have 0.8 of a square times 5, which still gives me 4 volts. Okay, so we still have 4 volts peak on the on the waveform because we didn't change anything in the vertical direction. And the period we didn't change either. We just now one complete waveform has 1, 2, 3, 4, 5 squares in it. Okay, so 5 times 2 milliseconds is still 10 milliseconds. Okay, 5 times 2. Okay. Okay, so we still have 2 milliseconds. We just, now that the waveform is just showed, we get 2 waveforms on the same screen now. Okay, so you need to draw this waveform on there. Okay, so this would be a time to stop the video so you can carefully draw this the way it shows up on the screen here. Okay, so now let's set the function generator frequency so that there is one complete waveform on the oscope. So I'm going to go over here and I'm just going to turn this knob. Okay, when I move this knob, you can see that I changed the period of this waveform. Okay, so I want one complete waveform. So it starts on the beginning of the first square, and I want it to stop at the end of the last square. Okay, so there we go. So there's one complete waveform on the screen. Okay, so we want to now measure the period of that waveform. I just changed the frequency. This time I did change the signal going in. Okay, so let's measure this. My scales per division is 2 milliseconds for each square on the horizontal, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares across. So 10 times 2 milliseconds, 10 times 2 milliseconds will give you the period. Okay. Okay. So I'll just write that down on my data sheet. You can do the calculation. The time per division is 2 milliseconds, and the number of squares is 10. Okay, so if there are 10 divisions at 2 milliseconds each, then that means that the period has got to be 20 milliseconds. Okay, so you go ahead and do that step. Okay, okay. Remember that the t is going to be equal to the time per division times the number of divisions. Okay, which is the number of squares. Okay, so there you go. Okay, so the period is the time per division times the number of divisions. Okay, and just for passing, let's say let's change the voltage scale to 2. Okay, let's change the voltage scale to 2 volts per division. And I'm going to increase the amplitude to a full scale reading. All right. So now, if you look at this waveform, let's find out what the peak voltage is. The peak voltage is 1, 2, 3, 4 divisions times 2 volts per division. So that should be 4 times 2 is 8 volts. Okay. So again, the voltage is going to be equal to the volts per division. Okay, I'm writing this down. Volts per division times the number of divisions, or the vertical divisions. Okay, so these are the vertical. This one is the horizontal. Okay, so this one here is going to be, like I said, the peak voltage is 4 squares times 2 volts per division, okay, which gives me 8 volts. Okay, so that ends part 1. Part 2 and part 3 will follow this. So let's sign off.